In this example, we're given two functions. F of x equals the square root of x plus 6, and g of x equals 2x minus 5. And we need to find these four expressions here. So let's start with part A, and we're asked to find f composed with g of x. The first thing you do is, what does f composed with g of x mean? All it means is f at g of x. And we always work from the inside out, so the first thing I'm going to do is replace g of x with its definition. So I'm going to have f at, instead of g of x, I'm going to write 2x minus 5. Now I have to figure out f at 2x minus 5. And this is where some students get confused because we have x's here and x's there. So remember, x is just a placeholder. If you put a little placeholder over your x, all I'm asked to do is put 2x minus 5 here and here. So let's just do that. So f of x says take the square root of my placeholder, which is 2x minus 5, plus 6. So all I did was replace this x with 2x minus 5. And so now the only thing left to do is simplify inside the square root. So negative 5 plus 6 is positive 1, so I'm going to get the square root of 2x plus 1. Can I simplify anything else in this expression? No, this does not simplify. So f composed with g of x is equal to the square root of 2x plus 1. Now we want to look at g composed with f of x. By definition, g composed with f of x is g at f of x. And so in this case, I need to replace f of x with its definition. So I'm going to get g at the square root of x plus 6. And now, remember, if you get confused, kind of put a placeholder around your x's in g of x. And I'm going to have to replace those x's with the square root of x plus 6. So g says take 2, multiply it by whatever I'm going to put here, which is going to be the square root of x plus 6, and then I have to have minus 5. Now, can I combine this 6 and this minus 5? No, the 6 is under the square root, the minus 5 is outside it. So g composed with f of x is 2 times the square root of x plus 6 minus 5. Before we go on, I want you to compare f composed with g of x with g composed with f of x. Do they give us the same functions? No, they're totally different functions. And in general, composition is not commutative. There are some special cases where it is, but in the majority of cases, composition is not commutative. So now let's move on to part C, where we have to find f composed with g of 4. Since I've already found f composed with g of x, the quickest way to find this is just plug a 4 into my definition of f composed with g of x. So I'm just going to get 2 times, what's x have to be? 4. So it's 2 times 4 plus 1. So I'm going to get the square root of 2 times 4 is 8 plus 1, which equals the square root of 8 plus 1 is 9, and the square root of 9 is 3. So f composed with g at 4 is equal to 3. And lastly, we have to find G composed with f of 4. Since I've already found G composed with f up here, all I have to do is replace every x in my definition with a 4. So I'm going to get 2 times x is 4, the square root of 4 plus 6, all underneath the radical sign, minus 5. So I'm going to get 2 times the square root of 4 plus 6 is 10, minus 5. And can I simplify this? No, the 10 is just 2 times 5. There's no perfect squares hidden in there. I cannot combine the 5 with the 10 because the 5 is outside the radical, the 10 is inside. So G composed with f of 4 is equal to 2 times the square root of 10 minus 5. One last thing I want to point out is we found f composed with G of 4 by plugging it into the definition we'd already found for f composed with G of x. But say we hadn't found this, there is another way of finding f composed with G at 4, and that's to find f at G of 4. So I need to figure out what G of 4 is. So I'm going to have f at, what is G of 4? It means put a 4 right here. So I'm going to get 2 times 4 minus 5. So that's f at 2 times 4 is 8, minus 5 is 3. Now we figure out f of 3, means put a 3 right here. So I'm going to get the square root of 3 plus 6. And what's the square root of 3 plus 6? It's the square root of 9, which is 3. Did I get the same answer here as here? Yes. If you've already figured out f composed with g of x, this is the quicker method. If you haven't, this might be quicker.